Okay, so this is to show you what the program should look like on the FPGA. So down here, you'll have these switches. This has 12 switches that you're using on here. The four most significant switches are not being used, and those are going to correspond to the data in bits. So going from bit 0 is the least significant, to bit 11 is the most significant, and those are going to be input data. So right now I'm doing this exact example, and on the waveform up here it's showing you this first example. So this is my data in bits, and then on the LEDs, let me move this syndrome down. The 8 least significant bits on the LEDs are your data out, so it's showing you that it's matching, so you have the same data out. Then the next 4 bits are your syndrome, and then the 12th LED here is going to be your your error signal. So right now we don't have an error. So now I'm going to do the next example, and in here I have this bit flipped, which corresponds to bit position 5, and that's going to flip D3. So if I do that, we'll now see that we have the syndrome 0110, and that corresponds to this position number, which tells us that we have an error in D3, and we also have the error signal. So now I'm going to flip that one back so that we have no error and no syndrome. And then I'm going to try this example, and in this example what I have flipped in here is a check bit. So all I have to do is flip this least significant bit out to 0. We'll see that now we have 1000 as my syndrome, and we have an error. So this code, just from these couple examples, you could try a few more using this figure 3 table and see if it could detect your error. So now just keep in mind that this can only detect one error. This is not a double error. So you can't cause it to have 2 errors, because you're going to get an erroneous syndrome and error out. It only can detect one error at a time.